Hello students, this is sdSIR again from the Temple of Excellence, Vidhyaashram Pre-University College, Mysore. My dear students, today we start discussing a new chapter, the second chapter from your first textbook, Electrostatic Potential and Capacitance. Before I go deep into the chapter, we will now realize the central idea of understanding this chapter. ಇಲ್ಲಿ electrostatic potential and capacitance ಈ ಒಂದು ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಆಗಿ ಏನನ್ನು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ತೀವಿ? ವೆರಿ ಸಿಂಪಲ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ದ ಕೋರ್ ಐಡಿಯಾ ಹಿಯರ್ is to understand the influence of potential energy on a charge which is placed in the electric field. Electric field ಅಲ್ಲಿ ಒಂದು ಚಾರ್ಜ್ ಅನ್ನ ಪ್ಲೇಸ್ ಮಾಡಿದ್ರೆ ಅದ್ರ ಮೇಲೆ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿಯ ಯಾವ ಇನ್ಫ್ಲೂಯೆನ್ಸ್ಗಳಾಗುತ್ತೆ? ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಟ್ರೈ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಅಂಡ್ ದೆನ್ ರಿಲೇಟೆಡ್ ಟು ಪೊಟೆನ್ಷಿಯಲ್, what is something called as capacitance and a capacitor. If you remember, in the first chapter I've discussed fields, charges, I've discussed certain definitions. All my concepts that were discussed in the first chapter significantly play a role understanding the second chapter. Therefore, in my today's session, my bird's view will be on the physical definition of electric potential and the so-called consequences of electric potential. Now, if you observe the title here, I have iterated the word capacitance, C and C, just to make you all understand capacitance is a direct outcome of a quantity called potential. Significance of capacitance is a result of something called electrostatic potential. Therefore, today's session I will be thoroughly discussing, I will be prominently highlighting on something called as potential. Now, in simple terms, let us try to understand what is electrostatic potential. If you recall the concepts of a source charge and test charge. So I have a point charge plus Q. Plus Q is the point charge. And what did I call that as? Source charge. Yatik source charge ant karde, it would have created an electric field. That is the reason I am calling plus Q as the source charge, which is actually my point charge. Now I have to test the influence of this electric field, the impacts of the electric field. So what did I use? Test charge, which was certainly my UPC. So at some distance from the source charge, I have a test charge which is UPC. So the source charge and the test charge. To recall, plus Q has created this electric field. It is the source of the electric field. The point charge is giving me the electric field. Therefore, it is the source charge. UPC tests the influences of the electric field. ಆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಏನು ಇನ್ಫ್ಲೂಯೆನ್ಸ್ ಮಾಡುತ್ತೆ ಅನ್ನೋದನ್ನ UPC ಟೆಸ್ಟ್ ಮಾಡುತ್ತೆ. Therefore, it is called the test charge. Now, as usual, what is the interaction between them? This is a positive charge. This is also a positive charge. The source charge exerts a force on the UPC. Electric intensity ಅಥವಾ electric field strength ಅಂತ ಕರೆದ್ವಿ. What is the direction of that intensity? Some type of force. I told both of them are positive charges. So force has to act away from the charge experiencing it, which is nothing but UPC. So the force will act away from the UPC. So the force is acting away from my test charge. So simple consideration. Point charge created the electric field. Therefore, it is called source charge. UPC tests the electric field. Therefore, it was called test charge. And the force, that is electric intensity, is acting away from the UPC because of the nature of interaction. Now understand, this is very important. ಗಮನಿಸಿ ಈಗ. I will consider a charge Q which I say is placed at infinity. Very important. Some charge Q, some arbitrary charge which is placed at infinity. ಏನು infinity ಅಂದ್ರೆ? What is the meaning of infinity? Mathematically, we say something very large. Infinity, far away distances. Allah. Here, the logic is something different. Any point which is outside the concerned electric field is treated to be infinite. Need not be at very far away distance from the field. Something which is immediately outside. A point which is treated outside my concerned electric field is called as infinity. So the charge Q is not within the field. It is outside the electric field. Therefore, it is treated to be at infinity. ಗಮನ ಹರಿಸಿ, ನಾನು ಕನ್ಸಿಡರ್ ಮಾಡಿರೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಂದ ತುಂಬಾ ದೂರ ಇದ್ರೆ ಆ ಪಾಯಿಂಟು ಇನ್ಫೈನೈಟ್ ಅಂತ ಹೇಳೋದಲ್ಲ. ಎನಿಥಿಂಗ್ immediately outside the concerned electric field is treated to be at infinity. So some charge is placed at infinity. This charge is outside the concerned field. Therefore, I say it is at infinity. Now understand, friends. I have to move this charge from infinity to the point A inside the field. A is a point which is inside the electric field. Q is a charge which is placed at infinity, which means it is placed outside the electric field. What am I doing now? I have to move. I have to push this charge from infinity, from outside the electric field to the point A inside the field. Will the charge have wings? Will it fly by itself? No. Then what has to be done? Very importantly, I have to do some work. I have to perform some work to push the charge from infinity to a point inside the field, which means some external force has to act on this charge so that work can happen. For what purpose? To move this charge from infinity to a point inside the field. So what should happen? External force should act on the charge. Some work has to happen. Only then the charge can move from infinity to the point inside the field. And my dear friends, this work done is what is called electrostatic potential. No exaggeration, simple terms. What is potential? Some amount of work done. For what purpose? To push the charge from infinity to the point inside the electric field. That work done is called potential. But if you observe, there are two key words which will also associate to define potential. The first thing is zero acceleration. The charge has to be moved with zero acceleration. Why zero acceleration? Very interesting, students. Now, I am applying the external force in a direction opposite to intensity, which is also the field. See, charge is coming inside the electric field, but the direction of intensity is outside the field, away from UPC. So your Newton's third law has told both this force should have same magnitude. The intensity and the external force applied should have same magnitude, but they are acting in opposite directions, which means the net force on the system should be equal to zero. I repeat again, I am pushing the charge inside the electric field. That is, the external force is acting in a direction into the field. But what about my intensity? It is acting in a direction away from the field, which means my external force acting on the charge and the direction of the intensity are opposite to each other. They have to be equal in magnitude. They should have the same strength, but they are acting opposite to each other. So what is the net force? Zero. We also know that force is mass into acceleration. If this force has to be 0. Mass cannot be 0. The charge will have a defined mass. The only option is acceleration is 0. Therefore, the charge is pushed with 0 acceleration. And very clearly, it is against the direction of electric force. That is what I told. Electric force acting away from the field. But the work is done to push the charge into the field against the direction of the electric force. So basically, what is electric potential? Some type of work done. ಏನಕ್ಕ work ಮಾಡ್ತೀವಿ? To push the charge from infinity to a point inside the field. What are the two criterions? The charge has to move with 0 acceleration, explained why, and against the direction of the electric force. And all these statements together, coalesce together, is what is called electric potential. So basic thoughts in your mind. Anywhere next, when I talk about electric potential, it is nothing but work. Work done for what purpose? Pushing a charge from infinity, a point outside the field, to a point inside the field. Two conditions: 0 acceleration and against the direction of the electric force. So mathematically we say, if W denotes the work to move a charge Q from infinity to a point inside the field, then potential V is always W divided by Q. Work done to move a charge from infinity to a point inside the field. So basic notation of potential is W divided by Q. What type of physical quantity is potential? Work helidini. So it has to be a scalar. Remember, electric potential is a scalar quantity. It has only magnitude, work. With SI unit, W is joule, charge is coulomb. Joule per coulomb, or the established SI unit for potential, is volt. We always describe potential with the unit volt. So just to recapitulate, what was potential, students? It was some type of work required for what? To push a charge from infinity. What was infinity? Point outside the field to a point inside the field. What were the two conditions? Charge has to move with 0 acceleration and it has to move in a direction opposite to the electric force. What type of quantity was it? It was a scalar quantity. And what was its SI unit? It was volt. Now, coming to the consequences of electric potential. Now, I mathematically told electric potential is W divided by Q. Now, when do I say potential of a charge inside the field is 1 volt. Under what condition V becomes 1 volt? So mathematically it happens only if W work is 1 joule and Q is 1 coulomb. So this mathematically V is 1 volt if work is 1 joule and Q is 1 coulomb. But statement wise, understanding wise, what is this? We say electric potential at any point of the electric field. Electric field ಒಳಗೆ ಯಾವುದೇ ಒಂದು ಪಾಯಿಂಟ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಅಲ್ಲಿ 1 ವೋಲ್ಟ್ ಪೊಟೆನ್ಷಿಯಲ್ ಯಾವಾಗ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತೆ? ವೆನ್ a work of 1 joule is done to move a charge of 1 coulomb. ಎಷ್ಟು ಚಾರ್ಜ್ ನ ಮೂವ್ ಮಾಡಬೇಕು? 1 coulomb ಚಾರ್ಜ್ ನ. ಅದು ಮೂವ್ ಮಾಡಲಿಕ್ಕೆ ಎಷ್ಟು ವರ್ಕ್ ಬೇಕು? 1 joule. From where? Again from infinity to that point. So 1 coulomb ಚಾರ್ಜ್ ನ ಇನ್ಫಿನಿಟಿಯಿಂದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಒಳಗೆ ಮೂವ್ ಮಾಡಲಿಕ್ಕೆ 1 ಜೌಲ್ ವರ್ಕ್ ಮಾಡಿದ್ರೆ ಆ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಪೊಟೆನ್ಷಿಯಲ್ ಎಷ್ಟಾಯ್ತು? 1 ವೋಲ್ಟ್. ಸಿಂಪಲ್. ಸೊ ಯು ಕನ್ಸಿಡರ್ ಎನಿ ಪಾಯಿಂಟ್ within the electric field. At that point, specifically you say the potential is 1 volt when you require 1 joule of work to move a charge of 1 coulomb from infinity to that point. Now, if you observe here, we call electric potential difference. Now, what is this electric potential difference? ಈಗ ಬರೀ ಪೊಟೆನ್ಷಿಯಲ್ ಅಲ್ಲ, ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಅಂತ ಉಪಯೋಗಿಸ್ತಿದ್ದೀನಿ. Now I assume the charge is moved to the point A within the field. Listen to me carefully. Now within the same field, inside the same field, I have to move the charge from A to B. Understand, A and B are 2 points within the same field. Now where is the charge? Q. Where it has to be moved? B. Again what has to be done? Work. Until the same conditions. This is called potential difference. Potential difference is the work done to move a charge from one point to another within the same field. Know the difference. Infinity to some point within the field, the work is called potential. If you are moving the charge between any 2 points in the same field, that is also called electric potential difference, and it has the SI unit volt. Now, initially I told the entire understanding of electrostatic potential is to know the potential energy of a charge. Then what is this electric potential? It is also defined as the potential energy possessed by a charge at any point of the electric field. Simple. You consider any point of the electric field. You have done some work. You have moved the charge from infinity to some point within the field. The potential energy possessed by the charge at that point is simply treated as electric potential. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಒಳಗೆ ಯಾವುದೇ ಒಂದು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಒಂದು ಚಾರ್ಜ್ ಎಷ್ಟು ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿನ ಎಕ್ವೈರ್ ಮಾಡಿರುತ್ತೆ, ಇನ್ ಸಿಂಪಲ್ ಟರ್ಮ್ಸ್ ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್. ನೌ the work done to move the charge, I say, is conservative. Why do I call this conservative? For the simple reason, I am worried only about the initial state and the final state to which the charge is moved. ಎಲ್ಲಿಂದ ಚಾರ್ಜ್ ಮೂವ್ ಮಾಡ್ತಿದ್ದೀನಿ ಮತ್ತೆ ಯಾವ ಪಾಯಿಂಟ್ಗೆ ಮೂವ್ ಮಾಡ್ತೀನಿ, ಇದು ಮಾತ್ರ ನನಗೆ ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಆಗಿರುತ್ತೆ. ಐ ಡೋಂಟ್ treat or consider the path in which the charge is moved. ಯಾವ ಪಾತ್ ಅಲ್ಲಿ ಚಾರ್ಜ್ ನ ಮೂವ್ ಮಾಡ್ತಿದ್ದೀನಿ ನಾನು ಅದನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಲ್ಲ. Then what is considered? The initial point, that is the state from where the charge is moved, to the final point, that is the state to where I am moving the charge. Therefore, it is path independent. It does not depend upon the path. The work is conservative because it does not depend upon the path taken. Now, writing the SI unit for or the dimensional formula for potential, we have told potential is work divided by charge, W divided by Q. Now, mechanically, how do I define work? We have told it is the product of force and displacement. So, work is the product of force and displacement. How do I define charge? We have studied current I equals charge divided by time. Entire thing clearly explained in your master chapter. Now just know, basically current is charge divided by time, or charge is current into time. I repeat, current is basically defined as charge divided by time, rate of flow of charges, or charge is current into time. Force, dimensional formula, mass into acceleration, mLT minus 1, displacement L, so it is mL square T minus 2. Current is ampere, time is T. So finally, when we say it is m L square T minus 3 A minus 1. I repeat, the dimensional formula for force mL T minus 2, mass into acceleration, displacement L, so m L square T minus 2, current is ampere, time. So when you simplify m L square T minus 3 A minus 1. So in my session today, I have clearly explained what is electric potential. It is the work to move a charge from infinity somewhere within the field, zero acceleration against the direction, SI unit volt. I have defined what is potential difference. I have given you the significance of conservative work. So when I come for the next class, I expect you all to be thorough with this. In my next class, we will do a book work where I will calculate electric potential due to an isolated point charge. Until then, thank you.